Hello, this is Professor Urbis-White. Today we'll go over a method called matrix method to solve two-dimensional systems of equations. Two-dimensional meaning two variables. Okay, here's the general method. What you need to do is you're going to write both equations as ax plus by equals c form. So x and y are on the left, and dx plus ey equals f. All right? And what's going to happen is you're going to put down an augmented matrix, which is going to be the coefficient of x, coefficient of y, and the constant. Coefficient of x in the second equation, coefficient of y in the second equation, and the constant in the second equation. Now, once you have that, what you'll have to do is you're going to use something called row transformations, and I'll just tell you what that is, to rewrite this augmented matrix that you put down in this form. You're going to have a 1 on the left-hand corner, and a 0 at the lower end, and a 1 here. So this is going to be a triangle, 1, 1, 0. And then you're going to have a P and a Q and S. All right? So what that is, this is going to be 1x. From here, you're going to get the y. And you're going to put that y into this equation, and you're going to get the x. And I'll show you how that works. But before I do that, let's look at what a row transformation is. Now, the row transformation is all numbers in a row can be multiplied or divided by a non-zero number. So you can take the whole row and multiply or divide by something. Then you can add the first row and second row, or second row to first row, subtract, or add or subtract. And you can actually switch the rows. Put the first row to the second, second to the first, if you feel like it. All right, so let me show you some examples. All right, so if I have a system like that, you're first going to pull x and y to the left and then leave the constant term on the right. So, and you're going to write down the coefficients. Coefficient of x is 1, coefficient of y is 3, and the constant is 3. You do that with the second one. Coefficient of x is -1, coefficient of y is 1, and the constant is -3. So where do you want to go? You want to do things to this so that you end up with some like that. You're going to have a 1 here, a 0 here, and a 1 here. And you're going to have some other numbers in there, but it is important you have 1 and 1 in the diagonal and 0 at the bottom. Now, let's look at that. I'm going to name these rows, R1 and R2. Now, since that 1, this is the order I do that. Do that first. Do this second. And do this third. Now, the first one is to have that 1 at the left-hand corner. Guess what? I already have that. Now, so that's done. Now, let's do the second one. Now, I need to zero this number. How am I going to do that? I can do this. Leave the R1 alone. I just write it. What I'm going to do is I'm going to add R1 and R2 and put it in R2. Look what that looks like. So leave R1 alone and add first and second, and you add them like that, and then put it in here. So 1 minus 1, that's 0. 3 plus 1, that's 4. 3 minus 3, that's 0. Does it make sense? Now what am I going to do? I want to go here. So it's 1, 0. This is supposed to be 1. So what am I going to do with that? So I will leave from here. I'm going to leave R1 alone. But what I'm going to do to R2 is I'm going to take and divide it by 4 and put it in R2 because I want to just 1 that number. So let's do that. So I have 133. Now 0. 4 divided by 4, that's 1. 0 divided by 4, that's 0. Guess what? Now I have it in the lower triangular form. So what you're going to do, you're going to take this row and you're going to go 0x plus 1y equals 0. 0x plus 1y equals 0. Now this one goes, and what do you have? Y equals 0. Oh, okay. Now I'm going to use that in the first row. What is that? 1x plus 3y equals 3. What does that mean? The y was 0, so it's 1x plus 0 equals 3. What does that mean? X equals 3. You actually ended up with a solution, and the solution is, let me write it here, x and y coordinate, x is 3, and y coordinate is 0. And I used the matrix method to solve this equation. All right, so let's do. And this was a consistent system because I ended up with a solution. Okay, I didn't need this page. Let's look at this problem. I put everything on the left, x and y, line them up. Then I'm going to put the coefficients negative 2, negative 4, 10, 3, 6, negative 8. All right, what am I going to do? So remember, I want to go here. I want to have a 1 here, 0 here, and a 1 here. It doesn't matter what's in here. So I need to do a couple of things. So what I'm going to do is I'm going to take my R1 and divide by negative 2 and put it in R1. That way, I will have 1 in here. So 1, negative 4 divided by negative 2, that's 2. 10 divided by negative 2, that's negative 5. And I'm not going to touch this second row yet. Now what I'm going to do, I'm going to take first row as is. Let's go here. Just leave it alone. Now I need to get rid of this 3, so that means I'm going to take that first row from here and multiply by negative 3 and add it to the second row and put that in the second row, second new row. Okay, so let's do that. So I have 1, 2, negative 5. So multiply this by negative 3 and add to that, so that's going to give me 0. This by negative 3, that's negative 6, and add to that, that's 0. Negative 5 times negative 2, that's 10 minus 8, that's 2. Okay? Did I do that one right? Negative 3, so that's 15 minus 8. No, that's not 2. That's 7. All right? Okay. Now let me use the second equation. So I have 0x plus 0y equals 7. That means 0 equals 7. Is that even possible? That's not possible. So what is the answer? No solution. So this system was an inconsistent system to start with. Okay. Let's do this equation. Okay. Negative 2, negative 4, 10. So I put the equations negative 2, negative 4, 10. I put 3, 6, negative 15. All right. So what am I supposed to do? The first one is I'm going to take R1 and divide by negative 2 and put it in R1 so that I have a 1 at the corner. Negative 2 by negative 2, that's 1. Negative 4 by negative 2, that's 2. 10 by negative 2, that's negative 5. And I'm going to leave this one alone. Okay. Now I need to zero this row. That's the second thing I need to do. So what am I going to do? I'm going to go and I'm going to take my R1 and multiply it by negative 3 add it to the second row, and put all that in the second row. Write these steps so that you can go back and correct. So I'm going to leave the first row alone and fill with the second row. So 1 times negative 3 plus 3, so that's going to be 0. So this one is going to be negative 6 plus 6, that's 0 as well. And this one is 15, negative 15, that's 0. What the heck happened? So I have 0x plus 0y equals 0. Is that true? Yeah, that is true. And actually, I can make that happen all the time. I have infinitely many answers to this situation. What does that mean? Infinitely many solutions. And guess what? This was a dependent system to start with. And this is the end of the matrix method.